Hi everyone, welcome back to Code Y, and we are back at it with another series where we build a game using Python. So today we are building a cult classic game. It is a game called Pong Game. I think it needs no introduction. It was almost like a revolutionary game when it came out, and for the purpose of the video I did some research and to show you some fun facts before we get into coding the game out. So yeah, about the game, Pong was like a tennis table themed game, and yeah, it helped usher in a whole golden age of arcade video games. So any video game that you see today that exists, like a gaming industry that exists now, like people had confidence the gaming industry can be big because of how successful the Pong game was. So Pong game was released in November 1972, and it was really expensive to own. So it's like a status symbol. Like it's not just for nerds or something. It was apparently it was really big. And yeah, it was the first phenomenal video game success, which gave the confidence that there can be gaming companies, and retro game as the theme started then. In fact, gaming on a digital platform kind of thing started from there. So that being said, this is how the Pong game that we are going to build will look like. On the right, we will have the good guy player, the good guy Petal, and on the left, we will have an enemy Petal. The good thing about Petal game that the Pong game that we are building is, as a gamer, you have full autonomy as to how you want to customize it. So, one simple customization that we can make in this is, we can change whether the game must play in an autopilot mode. Like that means if we want the enemy to be an AI controlled enemy, or if we want to just play with your friends, we can have a multiplayer version of Pong game as well. And it takes like maybe 1 or 2 lines of difference in terms of code. So yeah, that's the Pong game. In Pong game, there are 3 components: the ball bouncing mechanics. That means when the ball hits the wall or the paddle, it has to bounce in a realistic looking fashion. Like if the ball goes here, it has to go like this, something like that. It's just going to involve like really simple mathematics and the XY axis Cartesian plate coordinate adjustments. Otherwise, it's a really simple mechanic. And we're also going to have the enemy paddle AI, so-called AI. The AI will just to simply explain how it works, it'll just keep following where the ball is moving with a slight delay. So that means if the ball is here, the paddle will move like 1 inch towards that direction. That way we get a slightly realistic looking AI. And if we reduce the delay that the AI has, it will be super perfect. Like it'll be perfectly moving alongside, and the AI will never lose. But if we add a slight delay to how fast the AI can move, we make the game slightly easier for ourselves to win and play or whatever. On the right side, we'll be controlling this using W and S. And if the enemy paddle you want to play against your friend or something, you can just bind the keys for the enemy paddle to be up and down. That way you guys can have 2 people coming into play the Pong game as a multiplayer game. So yeah, if you're bored and you don't have any games and you're lazy to install a game, you can follow this tutorial and make a game for yourself and enjoy countless hours. There's a reason why this game was super successful, because people could just spend hours on the game. Anyways, with that, I think I'm done with my slides presentation. So let's jump into coding it out. So yeah, I use Canva for this. I'll click on idle. I'll open a new file. I'm using idle because I think most people would have idle if they have already installed Python. So as mentioned, I'll just save this quickly. I'll save it somewhere. Sorry. Pong game. Okay. So first things first, we're gonna use the turtle package for the snake game, like how we did for the snake game. So I'm gonna try to go as fast as possible because I don't want to make this into many different videos. Like I just want to minimize the number of videos that I'm making. Like I don't want to have multiple videos. That's what I'm saying. I'll import turtle as tx. Window is equal to. So first thing that I'm doing is I'm going to get started by building the the window. So window is equal to tx dot screen. So this gives us the playing arena. So window dot title will be Pong Game by at code Y or whatever your name is, which if you want to use your name. This is just for like our own purposes. There's no functional use for it. And I'm gonna set the background color. Use the American spelling for color. Background color to be, I'm gonna choose black, but you are free to choose your own ones. If you prefer to use more specific color items that you are interested in, you can try looking up the HTML codes, HTML CSS color scheme. That should help you get more unique colors. Otherwise, you have some basic colors like black, red, blue, green, white, these kind of things. And I want to set up this to be width is equal to 800 while height is 600. So it's a 600 by 800 pixel playing field. And with that, I'm gonna put win tracer 0. Oops. And I think we are, if we run this program now, we will be able to see, I'll just put a while true window.update. So yeah, this game in itself, the whole game, full game, can be done within 130 lines of code. So I'll just put the lines thing here so that you can see how many more lines we have. So 130, that's the target that we're looking at. So while true, Windows will update. So let's run this now. Save. Does it not work? So yeah, we have a empty screen like this. Oops. So yeah, now we have an empty screen. Nothing else is inside. So let's start by building the let's build the ball mechanics first. So as instructed by our slides, the first thing that we're building will be the ball mechanics. I won't go in order, but ball mechanics is something that's really interesting and needs a bit of math. There's a bit of math involved. So let's create the ball graphical image first. So the ball's graphical image, as with any graphical image in turtle package syntax, we'll be doing this. Turtle tx.turtle ball.speed. I don't want any unnecessary slowdown. Ball.shape will be circle. Ball.color will be white. And ball will have a pen up, because so what pen up and down does is, it is like, imagine if a pen is on the paper, we want to keep the pen up so that it doesn't leave a trace behind. If not, if we move the ball, there will be a line following the ball, which is not something we want. So ball dot go to 0 0 x 0 y 0, which is the center of the window. Next up, we are also going to set something called dx dy. So for those who are a bit younger in the viewing audience, these are called, dx and dy are gradients. That means at what like it defines the direction. So I won't go into explaining it because it'll take some time, but the main idea is that a combination of this 0.1 and 0.1 is it suggests that our direction that we're moving ahead is in this direction, like in a northeast direction. So yeah, that will be the initial ball arrangement. So now if we run this, you should see that the ball is right smack at the center. We need the Windows while true Windows update feature so that the ball gets shown over here. It doesn't move yet because I have not set the direction in which it has to move yet. So now what I'm going to do is I'm going to create the ball moving mechanics. Move ball. So ball dot set x. Ball dot x core, the x coordinate, plus ball dot dx. So x core as a method will get the ball's current x coordinate, which will be 0 at this point, and then I'm adding the dx. That means whichever direction that I want to move in the x direction will be put over here. So that's that. Same thing here, but this will be y. So set y. So set the y coordinate for balls dy. So with this, we should be able to see the ball moving in that direction, but it's not bouncing yet because we have not set the bounce collision mechanics. So let's set that now. Collision. So collision is a bit tricky because if you see this board, there's collision over here at the top, which is top is 300, bottom is negative 300, right is 400, left is negative 400. So think of it that way, and we need to find a way to make sure that if we hit some direction. So let's say if ball dot y core is greater than 290, that means the y-axis, it is greater than 290 if it's reaching the top over here. All I need to do is I need to flip the ball that's going up to go downwards. So what do I mean by that? So ball dot dy is going to multiply itself by -1. So if it was going up at a 0.1 speed, a -1 of 0.1, like if you -1 multiply by 0.1, you get -0.1. So an increasing y-axis will now become a decreasing y-axis. All this while the x-axis direction remains constant. So in terms of x-axis, you're moving in the same speed, but the up-down direction gets flipped by the multiply -1. So that's it. If you want to make it a bit more aesthetically pleasing, we can set the y to be 290. So this gives a more rigid feel. Like by doing this right, as soon as it touches here, it will readjust to 290 and then bounce. So it will look a bit more aesthetically pleasing. So with that, we are done at the ball bouncing for the top. Let's do the ball bouncing for the bottom. If it's lesser than negative 290, I will set it to be negative 290, and I will multiply by -1. So multiply -1 works still because when it's going downwards, it'll be -0.1. -1 multiplied by -0.1 will become positive 0.1. So yeah, sorry if I'm making it sound really like I'm talking to you as if it's nothing, but it's just to keep it as elaborate as possible, while keep the explanation as elaborate as possible in case someone is feeling lost. So if you feel like I'm making it too dumb for you guys, please let me know in the comments and I will change up. I'll talk as if I'm speaking to more adult audience. But anyways, we don't need to do elif, we can just do if. I guess we can do elif also, but yeah, it's fine. Ball dot x core. Okay, next up is the x-axis. So the x-axis operates the same way, except it's not 290, it'll be 390, and it will not be setting the y, it'll be setting the x. So x, and it'll be the same logic. Same thing. Lesser than negative 290, x-axis, negative 290, set x. With that, I think we should be good to go. So let's see. Bum 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 bum. Oh wait, why is it? Oh okay, I see what it is. I said 290. Wait, it should be 390. So we can see the ball is moving like a normal ball. It's bouncing around on the four walls. But if you think about it, right? If we have the petals, how do we lose? We lose if the ball touches the edges, this edge and this edge. We lose if we touch these. So we don't bounce from there, but we have to restart if we touch these walls at these sides, these two sides. We will create the paddles subsequently, but let's just figure out the ball mechanics first. So if the x coordinate is greater than 390, we need to declare endgame. That means we need to kill the ball and say go somewhere else or something. So first thing is I need to make the ball go to 0, 0. There's no bouncing yet. Let's copy this. Go to 0, 0. So let's run this. So yeah, it works. Like if we hit the wall, it dies and it starts from the center again, and then the direction that it takes is whatever direction it was going in the previous thing over here. I'm just so yep, it is okay, I think. So the ball collision part, the ball mechanics, I think is more or less set. The next thing that we need to do is our favorite thing, which is build the paddles. Oh, sorry. So let's say paddle A. Paddle A will be let's say paddle hero. I'm gonna call it paddle hero, and I'm gonna call it pad A. Okay, paddle A. Pad A will be another graphical image. Pad A will be turtle. Pad A. Copy paste this. Copy. Sorry. Dot speed will be 0 and dot shape will be a square. We will call it a square at first, but we will reshape it. I'm gonna give pad A color of dark blue. Turtle package is kind of nice to us in this way. It gives us some flexibility in the colors that we're choosing. If you once again prefer to have more specific color choices, you can use the HTML CSS color codes that can be found online. Okay, next up I need to reshape the paddle. So shape size, stretch width to be 5 and stretch length to be 0.5 and paddle A dot pen up. We don't want any traces to be left behind, and paddle A should go to -350 0. That means it will be the center, like in terms of x-axis it will be in the center, but it will be somewhere around here because this is 400, this is 350-ish. So yeah, with that, let's see if it works. Yep, we have a paddle over here. Right now, even we are not able to control the paddle because we haven't assigned any key values to the paddle. But yeah, let's add the next paddle. I'll just copy paste this. Paddle B, 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 and it has to go to +350, and I will say this will be dark red. So yeah, we have two paddles now. Both of them are not controllable because we haven't assigned any arrow keys to it. So now that we have done the paddles, let's assign the arrow, like a movement function. Like we need the keyboard to listen to us. So we need to do keyboard binding. Keyboard binding. So we will make the Windows listen first. Windows listen. Windows dot on key press. I'm gonna have a function say up, paddle A up, and I'm gonna assign W for this. I'll create these functions at the later stage, but right now I'm just having the keyboard binding thing to work. So up, down, red guy up, down. So this will be S, this will be, sorry, up, down, pedal B, down, pedal B up, pedal A, down. So now that that is done, we need to create functions for these 4 functions that I just called, because later if I press it, these functions will be called, but it has no definition. That means it's not defined previously. If I just run this, it'll give me an error. So let's create the function movement functions. Functions define function pedal up. Pedal up, all it does is I'm just going to control the y-axis of both these plate pedals, because there's no horizontal movement from just vertical movement. So I'm gonna find the y-axis first. So pad a dot do they have why am I doing this? Y cord. I'm getting the y coordinate first, and if I'm saying it must go up, I need to y plus equals 20, and pad a dot set y to be the new y, and that is it for paddle up. So paddle A down, it will work similarly. Y is equal to pad A dot y core y plus equals 20, my bad, minus pad A dot set y will be y. So with that, you can just copy this and paste it, and just change the pad A and to B, 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 B. Okay. With that, I think we are done. Hopefully no errors. So I can control this, but I'm not able to hit the ball yet because the ball mechanics only bounces against the wall, not against the paddles yet. We haven't set that feature yet, which we will fix now. So now that we have built all of this, let's build the next item, which is ball against paddle. Okay, that's, I'm sorry if any of this sounds wrong, because I'm gonna use a lot of I'm gonna say balls a lot of times, don't mind me. Next, under collision, we also have paddle collisions. I don't know why the color is not changing, but I think it should still work. Okay, paddle collisions is going to work like this. If the ball's x coordinate hits the paddle's x coordinate, we end it. I mean, we basically set the, we need to check on both ends, like if it hits the enemy's paddle or if it hits the good guy's paddle. We need to account for both of these variations. So if ball dot x core is lesser than negative 350, this is for the good guy. Sorry, we give a slight leeway, like the 350 340 thing. We give a slight leeway so that it feels more realistic to play, or feels better to play. Like there's some fluidity, that like flexibility that we have to allow for more fluid game experience. Ball dot x core greater than ball.xcore lesser than 340, ball.xcore greater than negative 360. Is it 350? 350, okay. And ball dot y core greater than pad a dot y core minus 50, and ball dot y core lesser than pad a dot y core plus 50. The reason why we do this is because we need to give some leeway for it to bounce. Like if it hits anywhere from here to here is 50, from here to here is 50. So we are saying that if the ball hits anywhere within this range, from this point, sorry, I'll use the blue one as an example. From this point, 50 points upwards and 50 points downwards, if it hits any of this, like if the ball is in this range, 350 to 340, that's the first part. Minus 340 to 350 is this range. If the ball is in this range and within this range, like plus 50 here, minus 50 here, we consider this an satisfying condition to bounce. So bounce is just going to be ball dot set x to be negative 340, ball dot dx is multiply equals to negative 1. The bouncing mechanics is just shifting the dy dx. That's all there is to it, nothing more. Okay, so that is for paddle collision for paddle A. The inverse is true for paddle B as well. Sorry, the color coding is not working right now. I don't know what's the reason, but the logic is the same. We're gonna check if it is within 340. Okay, I think it should be 360 if I'm not wrong. Is it 340 still? Okay, if the ball is lesser than 340 and greater than 350, that doesn't make sense. Greater than 340, sorry, yeah. Greater than 340 and lesser than 350. So greater than 340, lesser than 350 would be this range. And ball plus 50 and ball minus 50 is this range. So that should be paddle B's y coordinate over here. Paddle B, paddle B, paddle B. Paddle B y coordinate. And with that, I think we are good to go. I think we have a paddle controller now already. So let's run this. I think our game is done. So yep, there goes the ball mechanics. Now it's just a matter of scoring the thing. So yep. So now what we have is a multiplayer Pong game. To make this into a like a AI, like so-called AI based player game, what we need to do is, okay, before we go to that, let's figure out the scoring first. So for scoring, it's a really simple scoring. It's nothing complicated. If the ball hits the edge, like if it hits this edge, we are going to restart. That's all it is. So if it hits the ball, we will count 1 point for the other team. And yeah, so let me create a scoreboard system. Score will be pen is equal to tx dot turtle, pen dot speed is 0, pen dot color is white, pen dot pen up, pen dot height turtle, pen dot go to 0 and 250, because the top is 300, so 250 will be somewhere around here. Okay, let's say 260ish, and I'm going to write pen.write player 0, sorry, player A is 0, 1 2 3, 1 2 3. Player B is equal to 0. Close it. Center. Oops. Align. I'm still quite confused why I'm not getting the color coding anymore. I think I would have to update my idle for something. Font, I will choose pretty basic ones, but then up to you what you want to choose. 16 bold. With that, I should be able to see. Am I seeing something? I'm not seeing anything. Pen. So yep, the ball does update. Is it not hitting the red pedal anymore? Just now I think I saw something weird. Okay, yep, it does work. Okay, now that the pen thing works, I need to update the score. That means these are the losing conditions if it hits the sides right or left. If it does hit, I need to change the score. So to change the score, I first need to keep track of the scores. So I'll just write over here. Score A is equal to 0. Score B is also equal to 0. And I'm going to write that somewhere. So what I need to do is, if it is x-score is greater than 390, that means at this side, if I hit this side, player A wins. So score A must get 1. After score A gets 1, I need to pen.clear. So I'm clearing the drawing, and I need to write again. I need to write the score again. Write same thing. I'll just copy this whole line. I'm a bit lazy to type right now. Pen.write, I'm copy pasting this here. Player A, instead of using numbers, what I can do is I can put a curly braces here, dot format score A and score B. So that should do it, I think. Curly braces. I think all looks fine. So yeah, that is that for player A. If player A wins, so we need to copy this whole thing, copy and put it over here as well. Score B will increase by 1 if it hits negative 390 side. Score B will increase by 1, and the pen will be cleared, and then the new score will be updated over here. So let's run this now. So I hit the wall. Player A. Oh no, player A wins. That is odd. Correct. So if I hit the wall on this side, player A score will increase. Yes, correct. So yeah, that works. Now, if the game as it is ready, it is ready to be played by all ages, anything, it's fun, etc. But if I'm alone, if I don't have friends, which is quite a possibility, We don't shun people for that. If I want to play against the computer, I just need to add 4 more lines of code to allow it to be an AI so-called game. So to do that, we don't need to delete any of this. We can reuse these functions. If we want to control the AI, we can use this, but if we don't want to control it and we just want to play against the AI, we can do this. So whatever we did, so let's say if pad b dot ycall, it'll keep following the ball now. It'll be following the ball. If pad b's ycall is greater than ball's ycall, and the absolute distance between the pad b dot ycall and ball dot ycall, we are like basically subtracting the pad b's y coordinate and the ball's y coordinate, and we are doing absolute to find the absolute value is greater than 100. This is the difficulty that we're setting. That means if the paddle's y coordinate and the ball's y coordinate are like separated by like 100 pixels, which would be a gap of about this much, it will initiate the paddle to move up by 1 brick. So pad b dot pad b down. That means if paddle b is greater than if paddle b is greater than the ball, that means the paddle is higher than the ball. That means the ball is somewhere here and going around this area. I need to make sure the paddle follows the ball and goes downward, so I'm making paddle b go down. Likewise, the opposite, which is if the ball is higher than the paddle b is shorter, that means somewhere below the ball's y coordinate. This thing we can keep it as it is, greater than 100. Paddle b will move upwards by a little bit. So now we have a AI driven game, and now I have given the control to the AI. I'm not even controlling the AI paddle, I'm just controlling my side using W and S. As you can see, I made it a bit too easy for myself, that the computer is struggling to win. If I want to make the AI much better than me, all I need to do is go here and reduce the lag duration that I've accepted to be like lesser. And now if I try it, it'll be hypersensitive to it. It will be hypersensitive, move exactly where the ball is. It will have no delay. So that way the computer gets a bit harder. So if I want to change the difficulty, I just need to decrease the score over here, which is at what sensitivity do I move the paddle. So yeah, it just makes my life harder. But otherwise, it is a fun game for all ages. One of the most popular games of all times. So hope you guys enjoyed that video, and do let me know if you have any questions on any part of the code. My apologies for the code failing to have a color coding towards the end. Like, I'm not sure what happened. I'll probably look into that. But in the meantime, what I can do is I'll put up this code in some Medium article or GitHub or something and put it in the video link, and you guys can check it out. So yeah, that is my version of the Pong game. Hope you guys enjoyed it, and I will see you guys in the next video. Bye.